Good morning. Welcome to episode number 34 of the ZoomTown experiment. For today's testing and development, we're going to be focusing on utilizing the TCRT5000 photoreflective sensors for something more than their intended purpose, which was line following. After I got to thinking about that sensor, I came up with another idea on how I can utilize it, and it will help me potentially with localization. Now, as you know, we're going to be using encoders to track the position traveled of the Zoomie. And that's so far been working good, and we're about to test it even further today. But I wanted to have a sort of backup plan, something where I could verify I was at the position that the encoders are telling me. And for that, I came up with, essentially it's been called the white stripe idea since I thought of it. And what it amounts to is this: I will know where I start as I move along a roadway, at least in a straight line. So I'll know my starting point, and I know the distance I have to travel to get to the end of that road. But I have nothing there to confirm I've gotten there other than the encoder feedback. So to help validate that information, I thought about on a roadway. When we come up to the end of a road, especially in residential areas, you'll see a crosswalk, a white stripe across the road where you need to stop so that the pedestrians have free passage in the crosswalk. I thought, well, you know what? I could throw a piece of white tape on my layout and set that at a very specific position from either the start of the line or the end of the line. It doesn't really matter. But if I set it to a specific position, as I pass over it with the Zoomie, I can verify that I'm actually there. Furthermore, I could also detect if I've wandered off direction or changed heading. Now, in truth, I think that'll be a little overkill for what we're doing. I think line following has been working great so far, but it's using that sensor to its fullest capabilities. So to perform this crazy experiment and test, let's go over what we're going to do, and then we'll take a look at Test Track Z where I've got all of this set up. So what we're going to do is we're going to briefly discuss changes that improve the precision of the wheels. Then we're going to validate or verify the calibration of the distance traveled from encoder feedback, and that'll be tested in this experiment as well. And then we're going to use the TCRT5000 photoreflective sensors to help with localization. Now, what I mean by localization is helping the robot understand where it is within the whole environment, in our case, ZoomTown. For those of you with keen attention to detail, you may have noticed that the Zoomie I've been using had red wheels on it. And that's a 3D printed plastic wheel with a O-ring wrapped around it as the tire. Well, now I'm using green ones. Basically, it's the same material, but I did them in a different color so I could differentiate the red from the green. The green is off my newest printer. I'll be putting out a video talking about some of the changes, including how the work environment here looks different. I got ZoomTown to my back, and my back used to be over on that side somewhere, and that's where I got the new 3D printer. So we'll get you caught up on that in another video. But with that new 3D printer, it helped me work on a problem I've been fighting. One, the original wheels off my old printer are almost never truly round. They're all over the place as far as roundness. About a 0.5 millimeter out average, but it could be even more or less. 0.5 millimeter for us Americans would be 20 thousandths of an inch, 0.02. So out of round has been a problem. Plus, I also have a irregular shaped hole there, a D-shaped hole to fit our axle on the motor. And so I've got to go with that as right off the printer, go onto the axle. And even if I ran a broach through it or a punch to size the hole a little bit, it's always going to follow the angle. So what was happening as the wheel would rotate, it would wobble like this, and it would wobble up and down as it's rotating. Keen eyes could have caught it in the videos where you saw the Zoomy going along doing line following, but it looked like a fish swimming in water. Well, with the new printer, I took advantage of its precision. It's a much more expensive printer and higher quality, but my roundness on it has been within a couple thousandths of an inch, and we'll say about 0.1 millimeter or less roundness. And the perpendicularity between the axle hole and the face of the wheel has been exceptionally good as well. So now it runs very true and has less wobble. That'll give me greater precision in positioning and with feedback from the encoders. So that was a huge battle I've been fighting, and I was looking at a number of solutions, including a resin printer or even machining them out of aluminum using one of my CNC machines. But I think the new 3D printer solved that for me. So the Zoomy we're using today will be using the new wheels as well. Now the first thing we want to do in this experiment with the TCRT is to start looking at how we can see that line, the presence of that tape. So let's look at the layout here. You've all seen this before. This is test track 2. And nothing's really different on it. I've put down a few pieces of 6 millimeter wide or 1/4 inch wide paper or white tape. It's pinstriping tape that I buy off of Amazon, and I use several different colors here in the workshop. These two lines out here delineate the actual straight portion of this inner circle and this line segment specifically. This marker here we will be using as our crosswalk warning line for right now. But what I want to do to start this experiment, I first want to have the Zoomy drive over this white tape and see if it can differentiate between seeing the gray lines for line following and then the white tape. So we will position it about there. I'm only going to have about a 5-inch move for this test, and I'm doing that in the load trip plan function. And this will be elaborated on much more as we get more into it. But this is the instruction to get the Zoomy to drive following a line straight, FLS. And that means it's going to follow the line moving in a straight line. And it's going to go for 5 inches. Pretty straightforward for an instruction set. But this will be like in your car, the navigation instructions. It tells you which way to go and which direction to head in, and etc. So that's what this is all about. So we'll go ahead and run this. And while it's moving, we're going to come all the way up into our velocity control section. And we're going to look at line follow steer. And that is a subroutine or function that keeps the Zoomy moving along our gray and white line to travel in a straight line. And what I'm doing is right here, I want to print out the left and right line sensor raw values. These are coming right from the sensor essentially as analog value that we're converting. So let's see if we can see the paper tape and differentiate that from the background. So let's go ahead and run that. This is all the way back at the beginning. We don't go over 60,000, 58, 59,000, 61,000 on the left sensor. Right here, I see in this range here, well, actually we can almost call it this range. This is 62,000 which is higher than our previous and after. I'll bet you right in here is where we are seeing that white tape. We get over the 62,000 threshold. I know that's a fine line between that and the 61,800 right before it, or the 61,100s. So this is we're pushing the bounds of the capability of the sensor to utilize that data. So we'll see if we can't make another reasonable test here. What I've done is I've replaced that previous line we had in here to print the sensor readings. Now I'm going to look at that sensor reading, and if they're both over 62,000, I'm going to say that we are over the white line, and we'll print out the position of that. Now we'll see if it actually works. So let's run that test. We're set up on test track. Okay. Review that feedback, and look at that white line. We are seeing that, and that total distance, 1.896 minus 1.569 equals 327 thousandths, or about 8 or 9 millimeters. I think that's closer to 9 millimeters. So that's how far we're seeing that line. Yes, and with that, I kind of now know that it sees the line as being 0.3, rounding it up, 0.33 inches or 9 millimeters. So I'll make a note of that, 0.33 inches or 9 millimeters. That's how long it thinks that line is. I can see it, I can detect it, and I can differentiate it from all the other information that these sensors are reading. What I'm going to do now is get the Zoomy set up here at the far edge of that white line here. And I'm going to have it drive all the way to this point. And along the way, it should see this line. Now I've already calibrated the Zoomy for the new wheels, so we should be pretty darn close. So I'm going to take my tape on here, and we should be getting about, to get from there, for the front of the Zoomy, to get to here is 30.8 inches. 30.8. So we kind of already know how we can fix that in our program. We are going to scroll down right into this area here, and we'll change this distance to travel to 30.8 inches. I'll save that. Now when I run it, the Zoomy should travel in a straight line all the way across to this far line, passing over this stripe, and the front of it should be right at the front edge of that piece of tape. And we will, of course, track that in our program as well. We'll run it, see what happens. Oh boy, I think I overshot by just a shave. Fortunately, I think I got to work on the program a little bit, because it recorded a whole bunch of white line readings once it got to its destination. And I think I know how to fix that. I want to leave my white tape there for right now, but I'll bet you if I go over it with a black Sharpie, it won't look like the white line anymore at the far end. I just want to keep that tape there so that I can keep track of where this location is. Okay. All right, now we will align that again, clear that out, and we will run it. Now this would be the first white line all the way back here. this right here is this white line. We're at 25 inches out, and then finally it still saw the white line, but I could differentiate it with the dimension and with I'm flagging when the acceleration distance is calculated and when acceleration, or in our case here, deceleration. So now I can kind of see exactly what's happening as the zoomie moves along that line that we're traveling on. We see our first white line, our crosswalk. Here's the one in the near the end of the road. This is the one at the end of the road. So we've got our data. Now let's go into a little more analysis to understand what's happening here. Looking at the data, this is actually quite accurate. There's a few things that have to be taken into account to understand the numbers that we're getting. But first, let's start over at the layout to see what the numbers are here in Thani of 25.929 and 26.205. Where they are, then we'll look at the bottom of a zoomie, and then we'll look at a graphic and make sense of all this data. Here on the layout, the zoomie is exactly where it stopped at the 30.8 inches. We ran over this piece of white tape, and that gave us the 25.9 to 26.2 readings. Well, if you probably can't see this very well, but it's really, the tape is further back. It's at 25.7 to 26. Well, how come that didn't correlate? Well, let's take a look at what we're really looking at here. This is, let me try to get this up here. There we go. Okay, get that about like so. Now you'll notice that, I got to measure this. And of course everything I'm doing there is backwards to what I'm doing here. Bear with me, let me just get that set so that this will make sense. Okay, come on baby. All right, now if we measure from the front of the zoomie back to about midpoint on the sensor. So front of the zoomie to midpoint on the sensor is about 0.3 inches. About. Kind of hard to measure that. And on that sensor, you'll notice that if you've looked at one or if you've got one, let me see if I can get that to focus. At the front is the blue, that's the LED, and then there's a black bulb looking thing, looks like a black LED. That's the actual sensor that's looking for the infrared line. So I'm going from the front of this to right between those two and figuring that's probably its sensing position as best as we can figure out. Now I can refine that further with some other testing. Here in the graphic, you can kind of get an idea of what's happening. Now, these two little blue rectangles are the sensor. Somewhere about in the middle of that is what we're trying to figure out is where is the sensing position. We know that they're set back from the front of the zoomie. And this yellow area here would be, in this particular zoomie, it's coming out bright white because of the lighting here, but that front curved area is this front curved area of the bracket hole, or of the sensor holder, sensor bracket. And then the two sensors are set back further. So that's what we see here. And that is an offset that I'll have to put into any calculations with regard to where the sensor sees something versus either the front of the car or the center line of the axles. So I need to refine that as best I can, and I can come up pretty close right now, but I've got some other ideas that I'll probably try a little further down the road. But where we would see the front of the car during this, we saw the 25.929 number. That would have been the sensor seeing right here, or the front of the car being right there. The sensor was probably just starting to pick up the back of the line. And then when we got off of the white line and it quit seeing it, we were at a position of 26.205. So about 300 thousandths, actually a little less than that, 280, something like that. And that is 9 millimeters approximately. But the front of that, as we measured on the physical layout, is 26 inches. So we've got about a 300 thousandths of an inch, maybe 250 thousandths of an inch, 6 millimeters offset that I'll have to put in for a compensation value. And I'm going to make note of that right now. And as some of these experiments move on, I will refine that a little further. And I'm not going super critical on precision yet, because once I get over to the ZoomTown, I can rerun some of these calibration tests and fine-tune it further. But going back to the layout here, I overall think we've got a viable solution here for having a backup reading and to help with localization. Now, I will say the encoders for moving from point to point so far have been repeating fairly accurately. I'm going to say I'm probably within a millimeter of every test that I've done so far. That's plus or minus 1 millimeter, or about 3/32 of an inch in the inch world. So we're getting really, really close, but you never know what we're going to need once we start getting 16 of these zoomies running around on the layout and they're passing by each other, and we need clearances. One more thing I want to show you before we wrap up this video. I am going to put a body on here that I think is going to be pretty much where it will be when we're running. And let me go ahead and run the program and clear this out. Now kind of watch this area here. Now keep in mind the zoomie over here doesn't have a body on it. So these are always going to pass very, very close to each other along the center line. Clearances around the curves is going to even get tougher. So I never intended from the beginning for this to be easy. I've set up a lot of situations where I need precision in a scaled world, probably better than GPS can do, not the new stuff, but the old 1 meter resolution. I'm going to need precision greater than that in this scaled down environment. So there's lots of potential here for a whole lot of problems coming up in future episodes. So I think with that, we've proven out my concept. I can refine it further. It seems to be working reliably. And from there, I'll extrapolate on it further as we get further into this whole project. Next week, I am going to try to start working on all of the turning. So far, we haven't been focusing on turns. We've got what I'm calling a small sweep or a short sweep turn, a large sweep turn, and then when we go to park in the driveway, we can do one of two motions here, and I'm not quite sure yet because I've got to watch the clearance that I was just talking about. But what my original plan was to line up the wheels right at the center line of the driveway in this direction, then do a pivot turn and pull in. That's what I was thinking. But I got a hunch when I do that, the back end of this zoomie is hanging out in the traffic lane here, and that could be a problem. So I've got to think through that. So I don't know if parking in the driveway turning will be next or the sweeping turns, but one or the other we're going to be focusing on. We've got to get our little fundamental motions pretty well worked out before we start doing full-on following the traffic or the driving instructions from the scheduler. So that'll wrap it up for this video. Thanks again for watching, and I look forward to seeing you next week.